The superformula equation creates many shapes that resemble biological parts, and different inputs create many other shapes. In my previous video, I showcased you this animation. Now I will go through how to code this. Account for subtle differences between this animation and the animation in my previous video. We will use Turtle for this superformula equation animation. So we will import the module. Actually, import the functions from this module. And we will also be using mathematical functions to draw this. So we have finished importing the modules. Hooray! We need to start configuring the turtles, the tools of turtle. Speed 0, tracer 0. My turtle. I'll tell you what that means in a second, but there we have made progress in initializing. So speed 0 means the quickest turtle speed possible. And these commands refer to the original turtle set up at the beginning, not to any other turtle that I could possibly create. It just does not display any. This just sets the screen so that it does not display any frames unless you do screen.update, or rather just update this command. You can see here. Selected. The turtle can't be seen in under this mode. So we have finished configuration. Now we need variables and constants set. So these variables are just inputs for the equation, for the superformula equation, and we will be changing the m variable for this video, for the animation. This will configure the superformula equation to draw a sort of flower. And then frame quantity will be 400 to draw 400 to have 400 frames. And then increment speed equals 0.1, which is not really increment speed, but rather increment size, which is m, which is how much I'm going to increment every variable for the inputs of the mathematical equations. Right. And then we will go define how to draw the superformula. Oops. Radius. And then these are the inputs to the equation: m, n1, n2, n3, and then loops. So these are what creates the actual shape. Up. Why do we need this? To the first coordinate, and then for I in range 1,259 times loops. As we are going to have 1,259. We are operating a dot-to-dot technology here. the superformula equation converted from polar to Cartesian. So coordinates defining actually created uses a superformula equation and relevant inputs. Versus actually, I'm just gonna perfection this here. Yep, and actually a little bit more. Yep, perfect. And then x equals radius. Here we are operated a dot-to-dot technology where the computer solves the dot-to-dot game. So that's m times r. And 2 plus this is the whole superformula equation that I'm typing out, which is going to be very hard on the computer and maybe hard to understand at first, but I will display on the screen now the mathematical form of this. I think I messed something up. Yeah, I messed this up. And then it's all to the power of -1 and 1 cosine I divided by 200. Why are we using so this isn't really part of the formula, but it's the conversion to the from polar to Cartesian. So radius times, in fact I'm going to and we're just going to change no, we're not changing anything at all, we're just changing here because x corresponds to the cosine and y corresponds to sine. The cosine component is x and the sine component is y in the polar from polar coordinate system to Cartesian coordinate system. And then now that's done, plot it, draw it. Leave it the dot to dot. Now we will actually animate the 400 frames. You need a loop for this. And then m plus equals ink size, input increment, and then text is equal to, so there's going to be some display text at the bottom of the screen as I've shown you in the intro. So that's m equals plus string round m, 6. This plus, in fact I'm actually not going to do this kind of thing, I don't need to round it. String and then n1 equals plus string n1 and then rinse and repeats. And we don't want that. Subscribe to the channel. Click on the red button that says subscribe. Here we are now going to run this function to draw this. To be drawn out. This is going to be our location at the bottom of the screen. Oops, wrong way. I would have been to the left of the screen, the center of the screen. Yes, we got it. Right. Text. No, yeah. Font equals Arial. No. Equals Arial 20 normal, which is my favorite font, by the way, and the one I use most often. Align equals center, which is the American way of spelling center. Update. Displaying the So this is the best part about using Tracer as 0. This is the reason why I can do these animations in the first place, and so that they look very neat. But you can't see it until the next update command. And by the time that comes, the new frame is drawn, which means that you will never see the blank. And let's see if this works. And also, if you see any of the subtle differences between the here and the original video, be sure to post it in the comments. We are not done yet. This animation is much cooler. If you change these inputs, this happens. We get a double sub-spinning flower. And then we if we just change this, look at this. And before that, liking this, make sure to subscribe, because at this channel we have more of amazing creations just like this. I'm sorry, this is blocking here. And what if you do this? Oh, look at that. You like this kind of thing? And then, if you want cooler animations, if you want to go slower. But the disadvantage of this is that it will just make it much slower. I'm going to do the flower again, because I personally like the flower best. And I don't know why this problem is appearing, but check out the original. This animation is actually one of the much slower ones, because I've set this to 3 circumferences instead of 1 or 2, which means it's just going to be 3 times as slow. But you can also check out the original animation of my showcase on the left, on the screen rather, and subscribe to the channel. About the 3rd time I've told you to subscribe, now the 4th, and that's the end of the video.